Good morning, students. Today we will discuss a special case in a parallel combination in which the current is different in all the resistor. So we want to calculate a formula for each of the resistor for the current. So this will discuss in that particular segments. You see here is a figure in which two resistors they are connected in a parallel combination, and here is a current I, and when it passes through the resistor, as it is a parallel combination, so it distributes into I1 and I2. Here you see that there is a point A and B. So this is all about the figure tells you. From the figure you see that when you apply the characteristic of the parallel combination, due to the parallel combination, you see that current in a parallel combination, we know that the current distributed along the resistor. So that I distributed into the two resistor R1 and R2 in the form of I1 and I2. So this I is equal to the sum of the I1 and I2. Now according to the Ohm's law, along R1, when we apply Ohm's law in R1, then the potential V is equal to IR. So here is a V, and in the place of IR we put the I1 and R1. Likewise here we also apply same laws, that is Ohm's law, in the R2, and it becomes VA minus VB is equal to I2 into R2. Because why? Here is a VA or VA minus VB, and here is VA minus VB. Both are same because it is in parallel combination. In a parallel combination, we know that the potential along each of the resistor is same. So that will be equal. I1 R2 and I2 R2 is equal. Here we show you. I1 is equal to R1 is equal to I2 is equal to R2. And when we equate it in the form of I2, then we got that particular formula. I2 is equal to R1 by R2 into I1. Now what we do, we use that I2 in a equation 1. In equation 1, what we do, we put the value of I2 in equation 1. So I is equal to I1 plus, in the place of I2 we put the value of R1 by R2 into I1. So we put here, and after that what we see that there is a I1 and there is I1 in a in that particular case. So we take a common here, and then we got that expression 1 plus R1 by R2. And when we simplify it, then we got a formula I1 is equal to R2 by R1 plus R2 bracket 1 into I. It is a formula for current along R1. I1 is a formula for current along the R1, and this formula R2 is equal to R1 by R1 plus R2 into I. This formula applied to the formula when we want to calculate the current in a R2. So this is the formula for each of the resistor for current. So we can easily apply in the case of the parallel combination, or we can solve the numericals. We take a simple one example for implying that formula. Here is a two resistor R1 and R2, which is 10 ohm and 20 ohm. Here is a main current is 6 ampere, and that when this main current passes along the resistor, it distributed. So we want to know the I1 and I2 in that particular example. For that, what we do, we calculate the I1 and I2 in that case. For taking the help of that formula, we know that I1 is R2 by R1 plus R2 by I. We put the formula R2 is equal to 20 ohm and R1 is equal to 10 ohm and plus R2 is equal to 20 ohm, and I is equal to 6 ampere. When you calculate, then you got 4 ampere of current. So along the 10 ohm resistor, the current flows is 4 ampere. Now we calculate similarly in a I2 case. So in a formula, I2 is equal to R1. R1 is 10. R1 is 10 and 10, and R2 is equal to what? R 10 plus 20 from this formula, and we put into 6 ohm and then calculate. Then we got 2 ampere of current. So you see that what is the formula and how does that formula use in a numericals. So this, for this I1 it is a 4 ampere, for this I2 for 20 ohm resistor this becomes 2 ohm resistor. So this is all about that formula and their explanation. Thank you.